So imagine trying to push a flawless, completely uncompressed 4K video signal half a mile through a stadium that's just humming with electrical noise.
Right. With standard copper wire, you're going to hit a wall instantly.
Exactly. And welcome to today's deep dive. We are looking at the tiny piece of hardware that actually makes that impossible feat happen, the AJA FiDO-T-MM.
Yeah, it's an incredibly specific piece of broadcast tech. But, if you've ever wondered how a massive live event gets to your screen without glitching out or losing color, this is the secret. It elegantly solves the two biggest enemies in live video production, which are distance and electrical interference.
Okay, let's unpack this. At its core, the AJA FiDO is a one-channel transmitter that takes a broadcast standard 3G-SDI video signal, that raw, uncompressed feed, and converts it into a multi-mode LC fiber signal.
Right.
And to visualize why that's necessary for you listening, think about sending standard video over copper cables like shouting across a noisy stadium. The further your voice travels, the more it degrades until it's completely lost.
Yeah, that's a great way to put it. Standard copper wiring physically maxes out pretty fast. But by converting that electrical video signal into light through fiber optics, the specs on this transmitter become, well, game-changing.
How so?
We're talking about running signals up to 700 meters. That's nearly 2,300 feet when you use OM4 fiber, which is a specific grade of glass optimized for lasers.
Wow.
And even with older OM3 fiber, you still get an impressive 300 meters of range.
Pushing uncompressed video over 2,000 feet is wild. But wait, I get that light travels further, but earlier you mentioned this solves electrical interference too. How does changing the cable type fix the noise happening inside the venue?
What's fascinating here is the physics of what we call ground loops. So ground loops happen when different pieces of equipment like a camera out on the field and a monitor back in the booth pull power from different electrical grounds that have slightly different voltage potentials.
Okay, and the copper cable does what exactly?
Well, the copper video cables accidentally act like a bridge for that rogue electricity. And that shows up as like rolling static or a nasty buzz on your feed.
So the copper wire is basically catching the stadium's bad electrical plumbing.
Exactly. But photons don't carry an electromagnetic charge. By switching the transmission from electricity to light, you are physically severing that electrical bridge. The interference literally has no path to travel down the fiber cable.
You swap electricity for light to physically break the circuit? That makes perfect sense.
Yeah.
But here's where it gets really interesting, because I'm thinking about the reality on the ground.
All right, the logistics of it.
Yeah. If I'm a camera operator doing run-and-gun shooting, I can't be tethered to a massive, delicate fiber conversion rack. If this transmitter is doing that much heavy lifting, isn't it going to weigh me down?
You'd assume it requires heavy cooling and power to push lasers that far.
Right.
But it actually runs on a maximum of just 2 watts. Because it only sips power, it doesn't generate excessive heat. That means the engineers could ditch the bulky cooling fans entirely. Yeah, the result is a low-profile enclosure measuring just 4.6 inches long. It weighs only half a pound.
Half a pound. That's barely heavier than a smartphone. So you can just mount it directly to the camera rig and it won't throw off your balance.
Precisely. It tucks behind tight equipment racks, inside cramped broadcast trucks, or right on the camera. And if we connect this to the bigger picture, it doesn't strip away data to achieve that tiny size. It seamlessly passes through vital SDI metadata, including HDR.
So the viewer still gets that rich, high dynamic range color depth.
Exactly. Add in a robust 5-year warranty, and you have something built for the absolute chaos of live broadcasting.
So what does this all mean for you watching at home? It means that for about $905, this device serves as the unsung hero of the AV world. It takes massive, show-stopping limitations of distance and ground loop interference and completely neutralizes them.
Yeah, next time you're watching a massive live event, think about that noisy stadium. If a half-pound piece of metal can beam uncompressed, HDR-rich video flawlessly over half a mile of fiber while entirely ignoring the electrical chaos around it, how much of this invisible infrastructure is quietly holding together the broadcasts you watch every single day?